No. Did it? Talk to some of the people who were there, and oh, I'm live.
Graham would like. Hello. We're still a few minutes early, Graham.
You might need that.
Well, I want to make sure that the whole audience comes in. Good. Right. Good afternoon again, everybody. Thank you for coming to the final lecture of the session. I want you to read the instructions, Peter. So, if the fire alarms go off, leave orderly by the door, file outside, assemble in the car park outside. No recording of the lectures is allowed, audio or video, except the official RSGB recording. And please remember to switch your mobile phones off or put them on silent. Peter is unfortunately the person that is to blame for my radio affliction. Peter was the first person in the UK to work EME. Back in 1964 he had his first QSO. So he has now celebrated over 52 years of moon bounce, which is an achievement all of itself. However, back in 1972, when I was a relatively young man, along with a number of other people, we went to a lecture at the Winning Post in Witton in West London, and one of the key speakers down in the school at the side lectures was Peter, and Peter talked about moon bounce. And actually, I now know of at least 7 or 8 people who have been active and very strongly active in moon bounce ever since on all of the different bands that were inspired that day by Peter. So without further ado, Peter Bear, G3 LTF.
So thank you, John. Thanks, everybody. I mean, that was then, now is now. I just said to somebody, I haven't gone silver because my brother and I can still get the dye from somewhere. But I am 80 next year, so I hope you'll forgive a few ums and ers as we go through. And hopefully it's all going to work. So here we are. Right. So quite a lot of what I'm going to say applies to 3 SEMs as well. But Graham Murchie said to me, I see there's a lot going on 6 SEM EME. Why don't you give us a talk at the convention? And I said, well, you know, what sort of things do you want? I said, I don't really want to give, you know, a sort of basic talk on 6 SEMs. He said, well, no. You know, it's not for beginners. This has got to be, you know, fairly technical. So I hope it's pitched at the right level. So first of all, why do we want to work 6 SEMs EME? Well, I was just saying to Murray, 6 SEMs is actually the only band where you don't have to microwave band where you don't have to do any crossband working. The Australians are being pushed out of 9 SEMs to just below. 13 SEMs has got 4 segments, and on 3 SEMs, if you want to work the JAs, you've got to go up to, or you've certainly got to receive at 10.450. So it's quite nice from that point of view. Also, you know, it's quite a nice band from the point of view of the losses. You can still use SMA relays. Don't have to go to waveguide and so on. Next, I'm going to talk about 6 SEM issues, and then I'm going to talk about current systems. There'll be a lot of pictures of stuff in here, and then a little bit on transverters and system measurement. So on we go. Has that done something? Has that changed it? Oh yeah, good. Okay. First of all, just me. This is where I am. This is my original dish at Gallywood. I'm still Galleywood's still on the air with G3 YDY, working all sorts of good DX. But that started, as John said, in 64, 6 centimeters. I'm at 62 initials and 28 countries. So again, why 6 EME? 6 ME. I mean, well, I've mentioned the availability. There's lots of stations on the band. This is a curve that I put together. Stations active versus years. This is the largest number of contacts. Largest number of different stations worked by in the Dubus 6MCW contest, which is a weekend contest every year in the spring. And there's two things that really have contributed to this. There's the Dubus contest and there's the revival of activity weekends. I must say, I must claim credit for that, because about 8 years ago I said to people, why don't we have activity weekends like we used to in the 60s and 70s, when you just get everybody on at the same time and just work each other. You can use the logger, you can use whatever mode you like, but we just get the band activated. And that, I think, has contributed a lot to this curve. But here we are. The results aren't out yet, but there were 38 stations worked by the leading station this year on Dubus. So what else about Y6M? Well, you can get good results with 1.8 to 3 meter dishes. I shall show some 1.8 meter dishes later on. It's a good engineering challenge. I think that's why I'm still doing it after all those years. If you cut me through, it says engineering, and if you cut it diagonally, it says radio. So, and it's a great, what I call an experimenter's playground. As you'll see, there's plenty to do. It's not too hard to get the components. It's not perhaps as easy, well, it isn't as easy as the lower bands. There are some designs on the web. You can actually go out and buy it all if you want to. And the sky temperature is low. Just quickly to remind people, this is what the sky looks like at range of frequencies. 5.7 gigs, 30 degrees, sensible sort of elevation, sky temperature of 8 Kelvin. So what about the special issues that I mentioned in the opening slide? There's a Doppler, we're going to talk about Doppler shift and libration. I'll say something about antenna pointing. And then something you need to watch out for with mesh dishes. And we'll talk about mounting systems at the dish focus. So this is a curve that I made for Doppler shift at 6 centimeters, declination, sort of mid-range declination. Minutes are from moonrise, not terribly important. And you can see it's 9 kilohertz minus 12.5 through the moon path. Quite a large change. So you've got to be a bit alert with the when you're working split. Most transceivers don't have this sort of range available. It's nice in this middle bit where you can just use the RIT, but it requires you to keep an eye on the split. I've pointed out at the top there where the curve goes through, where the curve goes flat. The rate of change is 0, calling it a libration minimum. Now, libration, just very quickly, is the relative motion of the moon and the Earth, and it does actually go through a period where the motion of the moon and the motion of the Earth cancel out, and you get a 0 rate of change. I still find that hard to actually get my brain around, all those little hills and valleys on the moon and the craters and all the rest of it, and the Earth, and it's stable to half a wavelength at 6 centimeters. But I'm assured it does happen. So now so what I should say is, of course, what this causes is away from that minimum is a spreading of the signal. So this is Spectran, And if you were looking at, say, a normal tropo signal, no aircraft reflection, this sort of thing, this would be just a narrow straight line. For the time that this recording was made, and I hope the recording is going to play in a moment, Charlie, WDG, calculated the libration vibration spread as 78 hertz. So this was just a freeze of the screen that I made. So now if this is the key bit. Is it going to work? Did you move the cables, John? That's it. Right, pretty good. I'm glad that worked. That is a typical spread signal on 6 centimeters. Those of you that work 2 meter aurora will say, yeah, it gets worse than that. Well, it does on 6 centimeters as well. But the interesting thing is that, just quickly going back, at that libration minimum, it is T9. I looked forever to try and find a recording. I know I've got one, but I couldn't turn it up, so you just have to believe me. So antenna pointing. Well, you really should be pointing the antenna within the 1 dB beam width, not the 3 dB beam width, because 3 dB is 6 dB on echoes, and you probably lost them at that. So you really ought to, if you've got a 3 meter dish, you ought to be aiming to be able to point it to about 0.6 of a degree, remembering that the moon itself subtends about half a degree. So that's a challenge that in terms of stability and tracking systems and so on. I'm not going to say anything about tracking systems actually. I don't think there's time. Going on now to the effect of mesh on TSYS, which is the system temperature. Receiver sensitivity is the key thing, and the receiver sensitivity is determined by the system temperature TSYS. So a typical 6 SEM TSYS with a solid dish would probably be about 85 to 95 degrees Kelvin. Now, if you have let's say 8 by 8 millimeter, 1 millimeter thick mesh, you're going to add 51K to that, which is just not acceptable. You might want to note that the thickness of the mesh has quite a good effect. So 6 by 6, 1 millimeter, which is what my dish has, adds 18K. 6 by 6, 2 millimeters, and that's dropped to 4K. So there's a nice little trade-off here between the size of the mesh, the thickness of the wire, the weight of the mesh, and probably the cost. It's quite hard to find anything other than 1 millimeter. There's a spreadsheet on this in the W1GHZ online antenna book. Just Google. Mounting systems at the focus. So RF power is expensive. You've got to minimize the feeder loss, so you mount the PA at the dish, the focus of the dish, or use waveguide. And we'll see some examples of that. And mount the PA at the dish is quite interesting when you think some people use TWTs. So minimize the blockage in prime focus dishes. If you're using an offset dish, all that stuff is out of the focus, out of the line of the beam, so you can do pretty much what you like, as we'll see later on. Make some allowance for adjusting the feed position, and make sure you screen all units. I've had occasions when leakage from local oscillator boxes and that sort of thing, and even out of the end of evanescent guide filters, is enough to go into the dish and then back into the receive horn. And so when you're trying to adjust for sun noise, you move the box, and the phase of that source of noise moves and can falsify the measurement. Weather protection is not simple. I mean, I quite often use the Tesco or Sainsbury's method, I have to admit. So just a plastic bag. And when you're planning these things, put a multi-way cable up there with weatherproof sockets. So now we're going to look at some current systems. See how my timing's going. Of dishes and feeds. Now this is my dish. I'm not quite sure when this was taken, whether it was pre-2013 or not, but it all fell down in 2013 and got rebuilt. And if you go on to www.moonbouncers.org, you can see the story of that rebuild. And I rebuilt it to be much more accurate, and also with 6mm mesh over the whole dish. So this describes how it is. At the moment, it's 6 meters diameter. I'm fortunate enough to live quite a long way out in the country, and I was able to get planning permission for this to be there. It drops down into the ground. The mast that it sits on goes down into the ground, so that when it sits in the bird bath position, it's only actually at about 9 feet above the ground, and that's necessary because it's extremely windy, or can be. It's 0.375 F to D, which is sort of accidental, but it's about the right F to D ratio for dishes these days. This is the system. I'll sort of start with the transverter and work out, I think. So there's a transverter, and we'll look at that later. On the transmit side, there's a driver unit. I've got a picture of this in a moment. And then it goes into a solid-state PA, which gives me 40 watts at the feed. We use circular polarization, it's I can't remember now. I always have to look it up. Right hand up and left hand down, or it's in the books. But of course, you've got to remember that's the wave from the dish, not the feed into it, which is the other way around. So there's a control to stop you putting 30 volts on the solid-state PA without the gate bias. Otherwise, you end up with cinders very, very quickly. There's power supplies up there. Well, actually, the power supplies aren't up there. Power supplies are in this box underneath, and the cables are run up the side there. On the receive side, of course, there's the ubiquitous relay to prevent you from destroying the preamp, the LNA, the preamp, when you're on transmit. The relay switches between the antenna and 50 ohm load. If you make that line independent, you can always do a cold sky to ground measurement to check that everything is working and the relay's working. I think that's always a very useful thing to have. I just put a diode in somewhere, I can't remember exactly, years ago, so that I can actually do that. So first thing I do, is everything working? Click, click, yeah, noise goes up and down by 6 dB. The relay's working, it's likely to save the LNA. So at the other end of the transverter, the input is actually, I run everything up on one coax. So there's a diplexer at either end. And the this diplexer designs on the web. One side of it is fed with a oven control crystal oscillator. Happens right at 87.75. The other side goes to a 144 to 14 meg converter. There's a historical reason why it's not 28 megs. If you're here, Sam, I don't know. 14 is what I use. That goes into a TS850. Quite old, but very good HF rig. I hang an SDR off, which is a Rocky and a Spectran, and I have a tunable audio filter because I actually like to adjust the bandwidth to be roughly the bandwidth of that spread. And if you get into this and you start to work with spread signals on CW, it is worthwhile playing around with the audio side of things. So the next slide is a close-up of the arrangement at the feed without the Tesco bag. So here's the feed. I use on all bands now the designs by SM6 FHZ called QMAR feeds. It's a circular guide with a circular choke, a septum polariser. You know, the septum polariser enables you to have two opposite hands of polarization at the two ports of the feed. There's a little relay here, a little SMA relay, and then the LNA, which we'll see later on. The transmit side is fed from the 40-watt PA here. Next to it is the control circuitry I spoke about, and at the end there is a 4-watt driver, and the transverter is on the other side of it. The power sockets are I use a completely weatherproof. I think it's IP66 for the 30 volts and the 10 volts. The controls are actually D-type, but gold-plated ones, and they seem to last for a long, long time. Right, let's go on. Oh, I mentioned the 060. This is G8AC's 060. Very, very nice little units, very, very easy to build, and extremely good. These days, I think people would say, well, why not use synthesizers? That's certainly possible, and I'll mention that right at the at the end. So now I'm going to start looking at some of the dishes. So starting with some of the bigger dishes that are used on 6 centimeter EME. HB9Q in Switzerland is a group of guys who operate on all of the bands on moon mounts, and they're on the bands a lot. They're particularly on the contests and the activity weekends. They're a big signal, and this is the 10-meter dish they use for the higher bands. For 23 and 432, they have I think it's a 30. Is it 30 meter? Perhaps somebody else can remember. 20 or 30 meter dish, and they're very loud. This dish, some of you may have come across this because there's been quite a bit about it. This is in Holland at Dwingelo, and it was the original Dutch radio astronomy site, and the dish was sort of rescued. It was going to be taken apart, I think, probably about 8 or 9 years ago now. A bunch of guys got together. They managed to raise enough money to rebuild it completely. And there's, if you go and look on PI, go and look at PI9 CAM, you can see the film of them doing this. It is absolutely amazing. It really is worth a look. Anyway, they ran this up on 6 centimeters, and you can just see the feed box here. And what they actually did, they put the 6M feed inside the 23 centimeter one, with drilled 4 holes in the 23 cm one to make a little mount for the 6M. So that sits inside there. But they've only run it up with 10 watts, and they've only been on just a couple of times. Their main activity is on the lower bands. But there was a very interesting thing that happened when I worked them, and we go back to the libration on this. If you have a very, very narrow beam, you're not illuminating the whole of the moon. You're actually seeing less movement, less vibration. You're not seeing the returns from the edges. So the signal is narrower. And I was watching this, and I thought, yeah, that's really interesting. Well, actually, I was listening to it first of all, and I suddenly thought, right, what does my echo sound like at the same time? Now, my dish although it's 6 meters, it actually works pretty much like about a 4.5 meter one because of the irregularities and so forth. So it is pretty much illuminating most of the moon. So you can see the width of my echo compared to the width of the PI9 CAM one. So I had to rush around when I realized this would make a good recording. Managed to get Spectran up and running on the other PC and made the recording. So I think that's rather nice. Right. So moving on with the look at the dishes. OZ1LPR. This is a 2.4 meter offset dish. This guy has done really an amazing job. In a year, he's worked 58 stations. He is a serious operator. He's on 3 centimeters a lot. But this is his. This is with the 6 centimeter system in place. You can see from the annotations here, he's got a 100-watt PA. A look at the feed in a moment, and on most of these pictures, I've tried to indicate sort of where the driver is, the relay, and the LNA. You've got to get this connection between the port on the feed and the LNA as short and as close as possible, because 0.1 of a dB loss there is going to be about 5 degrees or so Kelvin, 5 or 10 degrees Kelvin on the system. You'll see where you go as we go through. Some people haven't sort of fully optimized that. So this is a really good setup. Here's an incredibly loud signal. And the feed, we were emailing a lot on this because he started off with quite a different feed, and what he ended up with, he said, "Oh, I found the original C-band feed horn for this dish. I wonder if that'll work, but it's the wrong size. So I think what I'll do, I'll take the this bit came from a feed that I described in the scatter point, which was a W2AMU dual mode feed with a scaled septum. So we took that. He just said, right, well, we'll taper it up over about, I don't know, probably 10 centimeters, 12 centimeters, maybe a bit longer than that. Bring it out to the size of the feed horn and put it on, and it works absolutely fantastically. It works better than anything else he was able to get going. So you've got to be innovative. Now I said 1.8 meter dishes, and I think the title of this slide, 1.8 meter dishes with 100 watts make CW QSOs on 6 centimeters. Now, obviously, less power than that, you can be making QSOs with the digital modes, with JT. I don't use them myself, but a lot of people do, and there's quite a bit of QSOs, quite a few QSOs being made using JT4 on 6 centimeters. So this one here, SM6PGP, he is a really, really good engineer. I've met him a couple of times. I've been to his shack. It's quite amazing, and he has a full mechanical workshop as well. This system is OK1DFZ is the neck. This 1.8 meter dish he bought in the UK. It's in 4 sections, 4 petals. But he couldn't get it shipped out to OK, so he got it to me, and then he arranged for some lorry to come and couldn't actually get to me, but it got somewhere near, and we put that on. It ended up in Czechoslovakia, in the Czech Republic. But bear in mind, when you've heard me speak about feed blockage, there's not very much on this one, but there's quite a bit on this one. This is his portable system. He takes this. This actually was when he was portable in Poland. So he's a brilliant mechanical engineer, and so this is everything that's needed, and it's got a handle on the top as a carrying case. So it's like a couple of U-bolts. Put this through, and you're on the air on 6Ms in some remote location. But the point to get across here is that you don't need a 3 meter dish. You don't need a 5 meter dish. A 2.4, 1.8 will do quite a lot for you. This is, I put this one in LX1DB in Luxembourg. This is Willie, a very old EME. He a very nice, neat arrangement, and it's fully waterproofed, very nicely engineered. 100-watt PA down here, quite a deep dish on that one. This is Jack PA3 DZL. Again, he's been moon balancing for a long time. This is his 6 centimeter system. His original one. We'll look at the new one in a moment. This is a mesh dish, 3.7 meters, 0.4 FTD, and he had, you can see up there, RA3AQ feed in. He has now replaced that with a very nice 3.7 meter solid dish. I think it's an Andrews, I can't remember now. And this is the feed system on a central pole. I hadn't got one of the the two together, but you can see how it works. It's got a very nice feed adjustment system here, so we can alter both the the tilt and the position to get it all working. And he uses see, just about everyone uses a different feed. He uses a Chaparral feed here with what's called a squeezed waveguide polarizer, and this was made by John PA7JB, who's also an extremely competent mechanical engineer. So this is the polarizer designed by CT1DMK. The two plates here are the bit of squeezed waveguide. You can see them. This is looking down the barrel, as it were, so you have two ports here, which are orthogonal. Works very well. For me, it's a bit more difficult to make than Septums, but there we go. This is Brian. Now, Brian was the first person to do 6 centimeter EME in the UK in 2005. He's got a very nice system. I'm sure many of you will have seen pictures of it before. It actually has a Cassegrain feed for 3 and for 10 gigs and 24 gigs. But when he's working on 6 centimeters, he has a feed system up here, obviously looking back down. And this, I got him to take some pictures of the tray for me. So he's got a square Septum feed with a choke, the relay coming out from the feed here, the LNA, which you can just see. Transverter is here, and the power amplifier, 40-watt PA, it's actually exactly the same as mine, is underneath, and this is the cable down to it. So, in fact, Brian has got some quite good weatherproofing. He found a waste bin that cut in half, just fitted over it. So, Deal 7YC visited my shack in 2012 when we had the EME conference, and he went home and copied the method I have of raising and lowering the dish. So, but this has been beautifully made with out of aluminium. It's a lovely dish. It's 5 meters, very fine mesh, works extremely well on 3 centimeters. I don't know whether he uses this on 24 as well. Probably not. I didn't have a picture of of the feed in there as well, but that's the back end of the feed that he uses, the RA3AQ type. And so out of here into the relay, load on the relay, and into the LNA. Right. Okay. JA4BLC. Again, somebody who's been on moon bounce for a long time. He has a 3 meter 0.25 FTD, so it's quite a deep dish, and he runs this with a Cassegrain. So it's a secondary reflector. So the way this works is the energy out of a feed here, look at in a moment, onto the Cassegrain reflector, which is actually a hyperbolic cross-section, roughly, and then back to the main reflector, and then across out from there. So this is the a close-up of the arrangement in the middle. Here's his LNA. The feed is actually what's called a WTIMU dual mode feed horn. You find all these on the web, and Yoshi tells me it just matches the Cassegrain plate that he's made. You can see here this is the original one for 3 centimeters, and he's made a bigger one, 60 centimeter one, to go on for 6 centimeters. So I try to get a selection of all the different systems that people are using to give you some idea. And as I said, at the beginning, it's an experimenter's playground. This is PA7JB, 2.4 meter offset dish, so you can put lots of stuff at the focus here, because the beam is going out above it because of the offset. He, as I said before, is an extremely good mechanical engineer, and so he's designed and made one of these. It's called a Potter or a Skobelev dual mode feed horn. The essence of dual mode is that you generate 2 modes in the system by this step, or you can do it other ways, but let's say it's done by this step, and then the length of this is such that they combine to give you just the right beam width, but with actually no energy at the edge of the guide. So there is then very low leakage back around the edge. So it's a very clean pattern. So for these offset dishes, the F to D, the focal length to diameter ratio, is probably about 0.7. So you need quite a narrow beam from the feed horn to illuminate it properly. But this is an extremely good system. John's worked 39 stations on CW with only 30 watts at the feed point here. So that's 2.4 meter dishes for you. This one, gosh, these are all we're all old EME. V4MA has given up Winnipeg for the winter, and he goes down to Arizona, and he decided he wanted to work EME down there as well. So he has a TWT. So the TWT is in his cabin and comes out on the energy comes out on waveguide, and then a piece of LDF 550 up to the feed point. He uses the same principle that I was talking about just now, the dual mode feed horn W2IMU, and what he's actually got here is 3/8 of a 10-foot dish. So he's just got the 3 panels, and he's illuminating it as an offset. I haven't worked him yet, but I'm pretty sure I can do it. I think it's probably about the same as a 1.8 meter offset. It's probably somewhere around about there. But he's a great experimenter. Again, you can see the relay and the LNA. Now this one takes a little bit of find the dish. This is WA6PY. Paul used to be started in Poland, went to Sweden, and then went out to San Diego, where this is. And I think his shack is this over the back here. But there's a 3.7 meter dish, and his feed support is a bit strange because he has these great long poles that come out to a point, and then these again quite long poles that go in to support the feed. I hope you can just about see the feed in there. He tells me he paints everything white because it gets so hot that he wants to try and minimize the heat absorption. But I think the next picture, so the TWT is mounted out here on the side of the feed support. So bear in mind, this is probably I don't know, it's probably got 15 kV on, or 12 kV or something like this. But it's nice and dry out in San Diego. I think he can probably get away with it. But another picture that I couldn't actually add in was IK3COJ, and he's in North Italy, and he has the TWTA out there under some polythene. So 6 centimeter transverters. Well, this is mine. I built my own. You can obviously buy them, and there are simpler versions, which we'll see in a moment. You can see the diplexer at the top there. And then that provides a signal to the G4DDK times 16 underneath, which goes into a doubler underneath here. So I come up with 5160 into this. It's a Watkins Johnson mixer that I happen to have a lot of from a discontinued project. And there are two filters, two cleanup filters in here. There's G4J&T has a nice design. I think it's on the website, isn't it? For evanescent guide filter, which is very simple to build and get going. And I did another one from modifying a 3-section interdigital filter. That was in Scatterpoint as well. So that's how I build mine. 144 meg IF, you do need filters. If you were in Sam's lecture, he talked about the need for this, and a good receiver filter to keep out the Wi-Fi. I don't have a big problem with Wi-Fi, but people in more built-up areas probably do. I only came across this as I was putting the talk together. It's a very simple, low-cost 6 centimeter transverter on FR4. It's on W1GHZ's website. It can use, you can either put a multiplier for the LO or a synthesizer. So there's a receive chain and a transmit chain, and the underneath here are pipe cap filters. So and it's described very adequately on the website, and that I think would be a very simple way of doing it. It's on FR4 as well. There's a lot of stuff on eBay, and there are these little 1 watt amplifiers. Don't ask me for the prices. I can't remember that sort of thing, but you can find them. And this one was says an 8 to 12 watt PA from a Polish site. I think there are about 3 left or something like that. But it is, the stuff is out there. I've gone the wrong way. No. Right. Trying to give a little bit about power amplifiers. If you have a look at www.moonbouncers.org, you'll find a very good article by SM6PGP on his building of this sort of amplifier. The key things, obviously the devices are not cheap. I think these are Cree, if I remember rightly. So these would probably be 2 60 watt devices giving 100 watts output. The heat sinking and the getting the heat away, getting the grooves cut in the copper substrate and so on is something that you've got to pay quite a bit of attention to. But quite a lot of people have made them. There's also some material on F6BVA's site, and F5JWF. If you go and Google on those guys' sites, you'll find boards there. Right, low noise amplifiers. Bit more difficult to find these on the web. This is my one. This is the one that I use. It's about 0.65 dB noise figure. It turns up regularly at Martlesham and other places to be measured. Transistor there, ATC capacitors. That's pretty much all it is. I made a master. I'm sorry, from an article that was written by, he was then WB5LUA. If you go and look in n5dux.com, you'll find a terrific article on low noise amplifiers for all of the bands above 13 centimeters up to 3 centimeters. And in it are drawings of the layout. And if you can find a bit of board, 2.2, and I think that's 30 mil board, you're away. And I've built them for 13, 9, and 6, and they work very, very well. So if, you can build your own. Somebody said to me, "Can't you go and modify existing C-band LNAs?" Well, yeah, I'm sure you can. It's just I'm not sure I've seen any. But we do it on 3 centimeters. So finally, a little bit about system measurement and system optimization. So sun noise measurement can give you an estimate of G over T, gain to temperature ratio, which is the key thing. In other words, you want maximum gain, minimum temperature. I meant to include a slide of EME Calc, which is a program that VK3UM wrote, and a number of us helped him with it. And sadly, because he's no longer with us, but it's still there, and it still works, and it's very, very useful. So you can put the numbers into that, you can measure the sun noise, compare what you get, and then start playing with the numbers to find out where you're not meeting up. In other words, you measure 15 dB of sun noise, and it says you should measure 17. So play around with the numbers to see where you might be making more improvement. Usually it's in losses. Moon noise can give you more accuracy than sun noise, because we're never quite sure of the spectrum of emission from the sun. Actually, we're going into a period now, of course, of quiet sun. It's around 85, 90, something like that, sun flux. And that's going to be quite useful, I think, for comparing data between stations. Moon noise give more accuracy. If you want to learn more about that, there's a paper that I wrote, which again is on the moonbouncers.org site. Goes into a bit more detail about that. Moon noise, of course, varies because the moon is sometimes closer or further away. That's all taken into account in the VK3UM program, EME Calc. It also takes into account the fact that if you have, excuse me, that the moon is comparable in a lot of cases with the beam width of the antenna. So you have something that's called a fill factor. So you have to correct for effectively the convolution of the moon width and the antenna beam width. Cold sky to ground measurement is something that a lot of people do, and it's quite useful as a reference. You always use the same sort of the same tree or wall or whatever, but it's more complex than it first appears because of the mismatch effectively of the wave from the antenna to the wall that you're looking at, or the tree, the transparency of the tree, if it's a tree or bushes or whatever. In fact, Doug and I tried to incorporate some of that in the program, if you use it, you really need to go and just read the notes. Oh, I did mention EME Calc, so EME Calc can help analyze the results. So I think I'm at the end. And I just want to thank everybody who contributed material. I put out a note on MoonNet to ask for people to send me photographs, and the community as it is, I was inundated. I've got enough for 2 talks, and so I try to make a selection to show as many different feeds and antenna systems and range of sizes and so on as possible. But that's a very good cross section of people who've helped. So thank
Peter,
you.
Thank you very, very much. Before we go for questions, perhaps we had a token of our appreciation for Peter.
Thank you.
So,
thank you, John.
after 50 years of EME, he's still at the leading edge. Any questions, please? Nobody got a question. Peter, I've got one.
Good.
When you look at partial illumination of the moon,
Yeah.
and you're looking at the libration minimum, it's counterintuitive, your picture, because I would have thought that because your reception aerial integrates the whole moon, and they're only illuminating part of it, that you will get...
Who's only illuminating?
The others...
oh, you mean the PI9
station.
one?
Yeah, the PI9 CAM one. I think that's counterintuitive.
That's not a libration minimum.
Oh, it wasn't at the minimum?
No. You only get the... that was... otherwise...
That was partial illumination, but I thought it was a dip in libration.
No.
Okay.
No, it was... I don't know whereabouts. I might have that in the logbook, but...
It's all right. My mind didn't quite get that the first time off.
No, it's perfectly okay. No, it is quite amazing. When you run echoes at at that libration minimum. I mean, earlier this year, I think it was in the 6 centimeter contest, I worked JA1WQF, and I could not understand why it kept fading out. I mean, like the sort of fade you get on 432 EME, just a long fade. I thought there must be something wrong. And there was no wind, so it wasn't the antenna blowing off the moon. It was actually a real libration minimum. Charlie, I gave the data to Charlie, and he said, "Yeah, absolutely, it's stationary."
That makes me playing EME still on the mechanics band at the bottom. Almost feel like somebody who's playing with Stone Age tools by comparison. So, Peter, thank you very much for an amazing talk. Let's offer our thanks to Peter again and then close the session.
Thank you. Thank you, John.